All right, now on to example 3 from difficulty 2. This is going to work exactly the same way as the first two examples, and we're going to use the substitution method. Remember, this only works if you have, like, whatever power you have here is doubled here. So here we have an x squared. The power doubled is x to the fourth. So that's what makes the substitution work, because when I substitute out, I then get a quadratic, just like in the last two examples. So as usual, we're going to start with our substitution of y is equal to x squared. Okay, so now we can rewrite this. We have x to the fourth plus 14x squared plus 40. And that's equal to, well, let's get this so we can see a lot more x squareds and replace them in a minute. So we have x squared squared plus 14x squared plus 40. Okay, now that I have all this in an x squared form, every place I see an x squared, I'm going to replace it with a y. So I have here, I have an x squared inside this parentheses, so I have y filling in this set squared. It's not because of this squared, it's because of this squared. So we replace this entire thing inside parentheses with that y. Now I have plus 14y, not y squared, plus 40. Now this is a standard quadratic that I could probably factor using the technique that we developed in the example 1, or in the difficulty 1 problems. So we're now looking for two numbers that add to 14 and multiply to 40. As usual, you want to start by looking at the factors of 40. So what are viable examples? The first ones that come to my mind, and the ones that actually work, thankfully, are 10 and 4. So if I multiply 4 and 10, I get 40. And now if I add them, I get 14. So I filled in all my blanks. I can basically rewrite this right now as y plus 4 times y plus 10. However, as I mentioned in the last video, we're not quite done yet, because why? We wanted a factorization for the stuff with x's in it. We replaced our x stuff with y stuff. So what we need to do is replace all of our y stuff with x stuff. So you get x squared, because of our substitution, plus 4 times x squared plus 10. All right, so at this point, this does not factor any further. So these are prime polynomials here. They cannot be factored any further. And at this point, we're done with the entire problem. This is a complete factorization for this expression here.